So hello and welcome to the 2018 D3R workshop. Yeah, sure. Hang on. So my name is Romy Amaro, and together with Michael, we co-direct the Drug Design Data Resource, and we're very happy to welcome you here today to our busy and activity-filled workshop. So this first talk will serve as a broad overview of D3R activities, and in typical co-directorship style, Mike and I will basically be splitting the deck. So around halfway through, I'll sit down and he'll take over. But we have this first segment is going until about 9:30. Okay, so just by way of history, for those of you who, just to remind you where this whole activity stems from, in 2004 and 2005, there were a series of meetings held at the National Institutes of Health where participants from pharma, academia, and the government came together to discuss what were the most outstanding challenges facing docking and scoring methods. And the consensus came to the fore that what we really needed were well-curated, high-quality data sets for common standard benchmarking and method development, and that would help accelerate the development of methods in computer-aided drug design. And so you can see some of the academic and government and pharma participants. Some of them are here today with us or dialing in remotely, which is terrific. But really, so in addition, the data sets really came to the fore as being something that needed to come through and be organized in some fashion, and where data sets in particular from the pharmaceutical industry could really help. And so, so the evaluation of protein ligand modeling methods, of course, what happens in general or in the field is that tests have been run with, when you're developing the methods, generally you have prior knowledge of experimental results. And of course, we also have the challenge that different methods are tested with different systems, so it sort of drives the need for common benchmarking systems that can be assessed in a prospective way, so sort of blinded to the actual results. And this is really, again, bringing home the value of having blinded community-wide prediction challenges. And so after much discussion, development of the RFA, concept clearance at the NIH, they created a special effort, this NIH U01, it's a cooperative agreement at the NIH, with a unique purpose, and that was to really try to broker the exchange of high quality data sets from pharma, to do this and academic sources, but to do this in a blinded way, and to make sure that the sets were high quality and consistent, and really up to the standard that would be informative for methods development. So the first funded initiative actually was led by Heather Carlson at the University of Michigan, that started around 2010. And then Mike and I took over the effort starting in 2014, and we sort of renamed it the Drug Design Data Resource. And so at the Drug Design Data Resource, or D3R as I think it's most commonly come to be known, our central goal is really to utilize these previously unpublished data sets as benchmarks for developers of computer-aided drug design methods, particularly with protein ligand modeling technologies. We'll also talk about how we have expanded a little bit of our efforts to also help run the sample challenges, which we'll talk about. That's also very important, obviously, for methods development. Our activities have a strong synergy with the existing public databases. So one of the other great benefits of this resource is that a lot of the data sets that we are pulling out of pharma otherwise would essentially just be in some sense abandoned in their sort of data warehouses, which are quite extensive. And so through this activity, we've been able to pull some of those data sets and actually bring them out into the public where they otherwise might not have seen the light of day, at least not at this time. And so it's not only the crystal structures, but also high quality affinity data. And this could be either generally in the form of KDs or IC50s. And, you know, the broader goals are really to curate these data sets, to extract these data sets, curate them, keep them blinded, use them in challenges, again, with the goal to drive improvement of CAD technologies, but also to foster an environment, education or methods, sharing and dissemination of methods and sort of the practice of the state of the art. And ultimately, of course, more predictive CAD methods benefit many people and many institutions and will lead, hopefully, to the more expeditious development of new and safer medicines. So the D3R project team is led by myself and Mike Gilson, as we've already mentioned. We have Ziad Gayeb, Connor Parks, Jeff Wagner, Mike Chu, Chris Church, and Jeff Grethe. Some of you undoubtedly have interacted with many of our personnel to date, either through challenge competition, through challenges or at meetings. We also have a second site at Rutgers, and this is led by Stephen Burley, who's also head of the RCSB PDB. And that team provides us with really terrific crystallography expertise and can help re-refine data sets, et cetera, so that we're sure they're to a common standard before we use them in challenges and they're released through the PDB. We have a really terrific scientific advisory board. So this is a very strongly community-driven resource. And as part of that, we try to take input, of course, from the broader community, but we also rely heavily on the expertise and guidance of our advisory board. And here you can see the members: Alan Edwards at the SGC, Chad Grimshaw, Takeda, David Mobley, UC Irvine, John Malt from the University of Maryland, Adrian Neufberg from Florida, Torsten Schwed from, he's in Switzerland, and Marty Stahl at Roche. And so some of them are here today. Chet is here, David is here, John and Adrian, and we're missing a few, but we have a pretty good showing today. So our goals, we see our activities as multifaceted. We have really, I think, tried to become a unique hub for the CAD community. In addition to the curation and extraction of the CAD data sets for the grant challenges that we've been carrying out, we also, of course, have developed a infrastructure to better handle, so that's ingestion and for ingesting these challenge packets, validating them, and doing assessments for both protein ligand and the sample model systems, as you'll hear about. We then carry out assessment and evaluation through various metrics. We do that internally as well as through external evaluators, who you will also hear from today. We also have a second effort that is aimed at capturing and disseminating workflows, and that is also involved or touches on something called KELP, which you'll hear about. And we also try to hold annual workshops, either in person, like we get to do this year, or last year it was in webinar format. And we also, of course, try to promote networking through those events and at ACS meetings and GRCs and so forth. Okay, so I'll give a brief overview of the different challenge types, and then I will hand it over to Mike for the second half of the presentation. So we have three main challenge types that really drive our core efforts. The first are the grand challenges, and these are where we're really focused on ligand protein receptor complexes, where we're looking at pose prediction and affinities or binding free energy predictions. We have also helped to carry out some of the sample exercises or sample challenges, and here in sample, the focus is more on simpler model systems where they look at affinities and then other physical properties of these simpler systems, and this has been mainly led, I think, in the most recent past by David Mobley, John Chodera, and Michael Schertz. And then, as I mentioned, we have a third branch of challenges that we developed called KELP, and this is a weekly challenge that is held in collaboration with the Protein Data Bank that Mike will tell you about, but it basically is weekly pose prediction challenges done in collaboration with the PDB. Okay, so the grand challenges, as most folks here are probably familiar with, when we run a grand challenge, we break it up into several stages. The first stage is really what we call the pose prediction stage, and the second stage would be the affinity predictions, when after the structures have been released. So in stage one, we're doing pose prediction and affinity predictions of multiple ligands for a particular protein. We piloted a new stage 1B in Grand Challenge 3, which is the one that we're going to focus on the scientific results of today. And that's where we release the co-crystal structures without the ligands to enable self-docking as a separate challenge. And this allows us to really isolate the evaluation of the docking algorithm because the participants are supposed to use the exact protein structure that the ligand was crystallized with. At that point, we then release the co-crystal structures with the ligands, and we have a second stage where people can predict the affinities again, knowing more structural information. And at the end of the day, all the data are released and deposited to the protein data bank, as well as binding DB. And often, well, we always have also a publication sort of describing the overview of results, but then there are ancillary publications also that feature this data. Okay, so so far in our efforts at D3R, since we took it over in late 2014. We ran Grand Challenge 2015. This was our first Grand Challenge at D3R. It had 35 participants and 355 submissions. We had 2 different targets, HSP90, where the focus was really on potency predictions, but it did have 8 co-crystal structures and 180 IC50s. This was data from AbbVie and the former CSAR project. The second target was MET4K4, which was more of a post-prediction challenge. They had 30 co-crystal structures, of very good resolution and about 18 IC50 data. Grand Challenge 2 came the following year that had an uptick in participants, 49 participants, 262 submissions, focusing on the FXR receptor, and this was poses and potencies, again from this. This was data from Roche, where we had 36 crystal structures and 102 IC50s with several different chemotypes. This year we've run Grand Challenge 3. That's what just concluded and what we will hear again the scientific results about today. This focused on, so we, knowing that we need to increase the statistical significance and the number of targets that we're actually testing our methods against, we, I would say, pretty significantly expanded the scope of the challenge components. So this actually had essentially 5 different subsets. We had a cathepsin S data set from Janssen Pharmaceuticals that had 24 co-crystal structures and 136 IC50s across a range of affinities. This had 27 participants and 303 submissions. And then we had a series of data that was co-developed by SGC and the University of North Carolina for compound creation, and then D3R actually contracted out KD measurements by DiscoverRx. And so this data set was actually designed in-house, and it was all focused on different kinases, looking at selectivity of different kinases, a couple of activity cliff data sets that were smaller, but where we saw that feature, and then another data set in ABLE1 where there were actually mutations to the protein, and we could see how that affected binding affinities. We also hosted, hope to host the sample blind prediction challenges, as I mentioned. This was started in about 2008, where originally they were looking at small molecule hydration free energies, and this was an effort started up by a number of terrific folks, including Ant Nichols, David Mobley, et cetera, folks in there. If somebody has a microphone on. These are mainly focused on simple model systems. So for example, looking at host guest binding affinities, looking at partition coefficients, pKa values, or hydration free energies for small molecules. And the thought here is, of course, that there are many advantages versus sort of real life protein ligand systems, which are much more complex. So the calculations are easier to converge. You can actually, of course, more easily carry out troubleshooting because you can, it's easier to basically isolate particular issues because there's reduced ambiguity in these model systems. So sample 6, which you'll hear about today and over the next and tomorrow also, focused on host guest binding affinity predictions, as well as had a pKa challenge. They had 124 submissions from 6 groups. I think this data is right for the host guest component of the challenge. And for pKas, they had 95 submissions from 10 different groups. Here they were looking for the 2 host guest systems were the deep cavity cavitan host. This is octaacid and subvariants. And then Q-curvitrol hosts, you can see here where they had 10 different guest molecules. And then the final challenge was centered on small molecule pKas. And the data The data, actually, I should have mentioned this, were coming from Bruce Gibb from Tulane University, Lyle Isaacs from the University of Maryland, and the small molecule pKas actually is from the experimental data coming from John Cadera's lab. One new aspect that you're going to hear more about from the experts, but that we just wanted to mention, is something that they call the sampling challenge. And what was sort of cool about this was that it allowed to test the efficiency of conformational sampling methods in a more direct manner, where everybody had the same host guest system, the same specific setup, and then they could actually test how the binding free energies would converge based on the number of energy evaluations, wall clock time, and total CPU time for different methods. And with that, I'll hand it over to Mike.
Thanks, Romy. That was great. And so now that Romy has introduced sort of the purpose and history of D3R and talked about the challenges, we thought what I would do would be to give you a little bit of an overview of some of the experiences we've had, some ideas for directions for D3R sample and perhaps the research community, and then say just a few words about the structure of the workshop. So one of the things that struck me, at least in getting the submissions for the protein ligand part of the challenge, is a wide range of methods. I had this sort of naive expectation that, oh, somebody would use a docking code, somebody would do free energy calculations. But what you see is that in addition to using a wide range of docking methods, there are a lot of other components of them. For example, you may, if you know the crystal structure of a co-crystal complex of a ligand that's similar to the one you want to dock into that protein, you can use that to help you with a ligand overlay method and not even do a full docking calculation. People use molecular dynamics and continuum solvent models to relax structures or to rescore structures that were generated with an initial fast docking method. And then there are a lot of combination methods. So you wouldn't necessarily say, oh, I did this calculation with gold. You did it with gold together with several other components. And so cataloging these things and understanding what the method was and interpreting what success or failure means becomes an interesting challenge that we'll be talking about and really be a theme through the workshop as far as I'm concerned. Similarly, for affinity prediction and ranking as opposed to pose prediction, there are ligand-based methods which are based not necessarily on structure at all of the protein, but on what ligands are known to bind your target and how can you learn something from that to score a new set of ligands. And then within the structure-based set, of course, there were what one might call low-resolution docking type methods that are fast, and then higher resolution free energy methods, if you will. And another thing that's been kind of fun to see evolve is the emergence of machine learning technologies in a number of these submissions. And I think that's going to be another interesting theme going forward. So one of the things we've tried to do at D3R and working with participants is to catalog some of the things we think we've learned. Those are actually on this website, but here's a subset of them. Some of the things we've noticed is that the accuracy of a docking calculation does not correlate very well with your choice of docking software. You could get good results or poor results with, for example, Autodoc Vena. And it has to do, if nothing else, with how you prepared the protein, how you prepared the ligands, what protein conformation you docked into, how you handled crystal waters, and perhaps other factors as well. There are also some, in addition, I mentioned knowledge-based methods where you knew something about the structure in advance could really help you, for example, by ligand overlay. And then there are a number of results that are sort of non-intuitive. Human inspection and intervention sometimes helps, but not always. Of course, it depends on the human. But we didn't, it's just this overall observation. And there are some real surprises. If people who use correct poses to do scoring didn't necessarily get more accurate results than people who use somewhat sloppier poses. Probably there are more errors in other parts of the calculation that are coming in. The use of in my view, the use of free energy methods to these simple host-guest system indicates that we need better force fields because those are pretty simple systems to get right, and we're still having some issues. And perhaps surprisingly, the explicit solvent-free energy methods have not conclusively outperformed faster host-guest docking and scoring or other composite methods. And then finally, we'll be talking today about how rigorous evaluation of methods turns out to be fairly non-trivial. There are statistical issues and judgment issues. We have a number of comments from participants about things that they found useful. This is from a questionnaire we had a little while ago. I'll just go, in the interest of time, go a little quickly. I would pay more attention to receptor conformations and flexibility. The challenges allowed us to validate our docking protocol. Docking seemed to be improved by machine learning, and I plan to incorporate such approaches, and so on. So I'd like to think that in addition to our sort of getting some overall pictures of things, people have gotten fairly fine-grained information about how to direct their own research and methods development. We are very appreciative of the Journal of Computer-Aided Molecular Design, specifically Senior Editor-in-Chief Terry Stout, for letting us come out with these special issues. There have been 4 so far. So there's one for Grand Challenge 2015, one for Grand Challenge 2, and then Sample had so many components. There are 2 special issues from Sample 5, and we anticipate, and we'll be giving more information tomorrow, that there will be additional special issues for Grand Challenge 3 and Sample 6. And this is really a nice way to capture both, as basically everybody who participates is invited to submit an article. They are reviewed, but I don't know if you've ever had to reject any. I mean, these are, it's a good place to put your results, and we also provide overview articles that try to extract some general rules about what's been learned. One of the things that we're really keenly aware of is that even with what we and hopefully the community are learning from the grand challenges is that they're kind of episodic, and there isn't enough data flowing through these challenges to really explore what is determining success or failure. And so we're keenly aware of the need to push for greater statistical power. And for this reason, we've taken a stab in that direction by developing continuous evaluation of ligand pose predictions, or KELP, which is a weekly rolling challenge, which essentially requires an automated pose prediction algorithm on the part of the participant. The basic idea, and this is really modeled after Cameo from the protein prediction world, which is an automated challenge in a similar vein. This is based on the fact that the Protein Data Bank, with thanks to Stephen Burley, the director who's here, that every week, Protein Data Bank gets a whole bunch of new structures out. And a subset of those, a significant subset, are protein ligand co-crystal structures, and a subset of those have ligands that are drug-like, bound to a protein of interest. And so the information on those proteins, their sequences, the INCHI string or SMILE string of the ligands, and some basic information about crystallization conditions like pH, as well as the idea of the forthcoming PDB structure release, are put out on the web about a week in advance. So the structure isn't available, and this poses a docking challenge. And there are something like 20 to 70, I'd say, suitable challenges that come up every week this way. So D3R, and you'll hear a lot more about this tomorrow from Jeff Wagner, graduate student here who's developed it with others, as Chris Churis and others, about how we package up the data sets, make them available to participants, bring back in the predictions, automatically generate root mean square deviation statistics, and some of the initial results we're getting from that. That idea of KELP, I mean, the KELP, you basically have to turn around your predictions in about 4 days. So you need automation. And the idea of automation and the idea of workflows is another theme that we'd like to encourage, and shows up in day 2 of this workshop. Because as I mentioned, the methods that people use are highly non-trivial. It's not just I ran Autodoc. There are many pieces. These are 3 different methods. These are summary descriptions that were provided to us. This uses 3 pieces of software. This uses 4. This uses a lot more. And so the question is, well, what is your method? If I describe it in a paper, can you use it? Actually, can you implement it yourself? Can you replicate these results? So the idea of capturing some of these specific methods in workflows, so the idea is to be able to essentially fully describe the methods by actually being able to disseminate them, to reproduce the results, to evaluate them on new data sets, and ultimately, if something is successful, to put it into application. And so we think the need for this and the value of this is something that has really emerged, I think, through some of these challenges. So along the way, we've developed a web portal which provides overall information on the D3R project. Each challenge has its own page as it develops. So there's some overall information, and these are sub-challenges that are not in high enough resolution for you to read, but many of you will have worked through this. Once we get the predictions in and the challenge closes, We generate summary statistics, at least an initial set. We look to our external evaluators to provide additional analysis. And these are put up in the graphical and tabular form. And as you'll talk about later, we try to make as much raw information as available as possible. So if you want to download exactly what the participants submitted and do your own analysis, you should do it. And then finally, the data sets themselves actually go up. Once the challenge is closed, we assign them a DOI so they can be referenced in a stable manner, and the data themselves, as Romy mentioned, are deposited respectively into the PDB and the binding DB. And finally, we try to capture some of the things we've learned. This is the What We Have Learned page from these processes for general use. So I'll finally go into just a brief overview of how the workshop is structured. So we're somewhere up here. We're looking forward to hearing from Peter Lister, our program officer from NIGMS, right after I talk. And then we'll move into an overview and then participant talks for Grand Challenge 3. That'll take up the morning. Except we'll also have an open discussion of evaluation metrics. So we can finally have a good discussion of medians versus means and Kendall's tau versus RMSD, and maybe not settle anything, but at least get the issues out there. Then we'll have lunch, and then in the afternoon, we'll be focused on various aspects of the sample challenges with overview talks and participant talks. And we'll have a poster session with some refreshments starting around 4, or about 4. And then dinner here, and if it's not raining too hard, you can sit on the patio, and then back to the hotel. Tomorrow is going to be more of a broad perspective kind of day. The morning we'll have talks from an evaluator and various participants who've been involved in multiple challenges, sample and grand challenges, to say, well, what have we learned and what are their perspectives? Then we'll take a break and talk about various aspects of workflows, starting with KELP, and then moving on to other aspects, and have a discussion about that as well to see if we can work towards workflowizing more of what we do. Then lunch and a group photo, and then finally an update on sort of where D3R and sample may be headed, and then really input from you as to where we should be headed and what directions may be. We'll finish around 3:30, except for the SAV and we who have a little bit more work to do. So to conclude, what am I doing? Practicalities. So you've had breakfast this morning. There'll be breakfast here tomorrow morning again. Lunch here today and tomorrow. Dinner today, also here, right out in the same area, but not tomorrow. We'll have adjourned before then. So some of you may have discovered the shuttles, but there's shuttles in the morning here from the hotel and then back in the evening. And Friday a little bit earlier. We're thrilled that a number of people have brought posters. For those who haven't figured it out yet, we're just sticking them up on the walls. So just use the blue tape so that the walls don't tear off when you move your poster. And I want to thank Megan Murphy and Iris Villanueva, who I think are outside. Yeah, but they've really done tremendous amount of work, which we appreciate, organizing this. And if you have questions, they're good people to go to, as well as any of us from the D3R team. And I'd like to, Romy and I really would like to thank many people, not all named here, but the rest of our D3R team, both at UCSD and at Rutgers, headed by Stephen Burley, our D3R Scientific Advisory Board that Romy reviewed, our co-organizers for Sample, Terry Stout and the folks at Jake Hamdy for the special issues, Peter Lister, Peter Preusch, and Jana Worley at the NIH for their support and guidance in all of this. Many data contributors, too many to list here. These are the most current. These are the folks who provided the sample data, and these are the Grand Challenge. Our external evaluators, Nation Evans, Mill Lambert, and Pat Walters, who you'll be hearing about today and tomorrow, and then all of you challenge participants for having the courage and motivation to participate. Thank you. So it sounds like we have a minute for a question or two, or our thoughts.